Start with inverse of the matrix, inverse of a matrix. Here we have written AB equals to IN, that is identity matrix of nth order, equals to B into A, right? So first you have to know what is inverse of any matrix. Clear? Suppose you have one square matrix is given A. You have to check the order, right? Matrix, you can find out the inverse of the given square matrix only when the given matrix will be invertible. The case of invertible, if that matrix will follow, then only for the given square matrix you can find out the inverse of the given matrix. Am I right? So this is nothing but if any square matrix is given, you can find the inverse of that square matrix only when if it will follow the property of invertible, right? So if, what is the invertible case? That is, if the matrix, suppose A matrix is given, suppose that A matrix is given, if B is such a matrix, what is the case of invertible? A is the given matrix, given square matrix, right? So if we multiply A with B, so that the value will be identity matrix. Identity matrix of same order. N is also the order of A, right? This is also if that matrix on that side, if we multiply with A, the result will be same. Then only we can say that A follows the property of invertible, right? So you can find out now the inverse of the given matrix. Here the given matrix is A. Now you can find out the inverse of that matrix. So which is nothing but this is possible only when B will be your A inverse. So you can write A into A inverse, or A inverse into A is I. This is the only case where you can do this, and this is the case of invertible also. So what is the formula? How will you find out the inverse of the matrix? A inverse is nothing but equals to 1 by determinant of A into adjoint of the given matrix A. Here the important thing, as that determinant part is in the denominator. So determinant value, you know that it may come any negative value, it may come any positive value, or zero values, right? So if the value will be non-zero, that is the matrix is singular matrix, right? And if the value of the square matrix, that is the determinant value of the square matrix, is 0, then we know that the matrix is known as singular matrix. So first you have to check whether the given matrix is singular or non-singular. Inverse you can find out only for the case of if the given matrix is non-singular. For the case of singular matrix, we cannot find out the inverse, as the determinant value is in the denominator, and you know that 1 by, if for the case of singular matrix, we know that the determinant value is 0, and you know that 1 by 0 is undefined. So you cannot apply. Here the condition is written determinant of A not equals to 0. That is nothing but A will be non-singular, matrix, right? So if determinant A will be 0, That is, if A is singular, it will not be invertible. Clear? A inverse, whole inverse equals to A. This is the first property. AB whole inverse equals to nothing but B inverse into A inverse. This is nothing but, if we product A and B, if we multiply A and B, the two given matrix, after that if we find out the inverse of their product, the result will be same as if we find the inverse of B and if we find the inverse of A and their multiplication B inverse, provided B inverse will come first. So this will be same, like you can get the similarity with this. For the case of adjoint also, B will come first. Okay, so adjoint of AB is also equals to adjoint of B into adjoint of A. Here also in the same way, A, B, C whole inverse equals to C will come first, C inverse, then B inverse, then A inverse. So now come to the next property. Here this is given A into adjoint of A. If we find the product, suppose A is a square matrix given, we have to find out the A product with its adjoint. Then without solving any adjoint value, any cofactor is not required. You can directly use the property and you can find out the product of A, the given matrix, with its adjoint, right? A into adjoint A. How it works? Only one thing you have to solve, that is the given square matrix A, you have to find out the determinant value. So you can directly write determinant of A into identity matrix of the N, where N is the same order with the matrix A, right? So this is nothing but the, also we can say that this is scalar multiplication of identity matrix, right? Now come to that property. This is very important. This property, and this property. This is also important for short question as well as for JEE, right? What it is? One matrix A will be given, but its structure will not be given. Only the order N will be given and the determinant value will be given. Then you can directly applying this property adjoint of A. Determinant of adjoint of A is nothing but whenever you will get the value of the determinant value of the original matrix and the order of the original matrix, just determinant of the given matrix whole to the power 1 less power of the order. Here adjoint of A transpose is nothing but adjoint of A whole transpose. The result will be same. Here adjoint of A. So one matrix, if A is given adjoint of A, then again you have to find out the adjoint of A. So directly you can apply this property and you can find only two things is your requirement provided in the question. Determinant of A will be given and order, that is N, will be given. So whenever you will get N, order of the given matrix and determinant value of the matrix, so you don't need the structure of the matrix, you don't need the elements or what the matrix structure, you don't need all of this. You can directly put the formula, you can directly apply this property and you can find the value of adjoint of A. Now what will be the determinant, the next step of it? What will be the determinant value of adjoint of A, which is nothing but determinant of A whole to the power. As you know, the order of A n minus 1 whole square. So these are very important, and after that we'll continue in that part. This is only for the case of JEE, because in the board syllabus, in the CBSE board syllabus, product of the determinant is not there. So product, this is nothing but the product of the determinant. Two square matrix A and B is given. Its determinant value will be the product of the determinant of A and determinant of B. How it works? Where is the application portion? Suppose you have A into A inverse equals to, you know that, I. If we take determinant of A into A inverse, then both side determinant, and you know that determinant of any identity matrix will be, its value will be always 1. So if we apply this property here, we can write determinant of A into determinant of A inverse equals to 1. So determinant of A inverse equals to 1 divided by determinant of A. This is very, very important, right? So determinant of A inverse will be equals to 1 divided by determinant of A, right? Let's start with examples of how to find the inverse of a matrix. In the first example, in our study material, for 2 cross 2 order, one matrix A is given 5, minus 2, 3, 1. In the regular way, first you have to find out all the minors, or directly you can find out the cofactors. These are the cofactor rows. I'm zooming. These are the cofactors. Then find the adjoint, put the cofactor values and its transpose, as we know that adjoint of A is Cij whole to the power T. This is nothing but the transpose of cofactor matrix. So first you have to find out the cofactors, then adjoint, transpose of that cofactor, replace all the elements and put the cofactor values, then its transpose. Here in the shortcut, in the previous tutorial, I have mentioned that here the steps are also given: step 1, step 2, interchange the places and without sign exchange, and then just opposite of the sign of these two elements, you can get the adjoint value. Now for 3 cross 3 order, one matrix is given, that is, let it be by A 0 1 minus 0 1 2 1 2 3 3 1 1. This is the given matrix. So first, to find any 3 cross 3 order, first you have to find out the determinant value, so that determinant value is required to find the inverse, and you have to check whether the determinant value is 0 or non-zero. If this will come 0, directly you can write, we cannot find out the inverse, because inverse of any matrix will be applicable only for the case of non-singular. So here the determinant value of A is minus 2, which is not equals to 0. So A inverse exists as A is non-singular. Now you have to find the minors, you have to find all the cofactor values. Then in the second part, you have to find the adjoint. Just put the cofactor values. You have to put the cofactor values. Then it's transpose. Here the transpose I have written. Then A inverse equals to apply just the formula 1 by determinant A into adjoint of A. We know that the determinant value previously it was here, the determinant value was -2, determinant value was -2. So just write the determinant value here over there into its adjoint. Then this is nothing but the simply in that step scalar multiplication, right? Here also in example 3, one diagonal matrix is given, but the diagonal elements are A, B, C. You have to find out the A inverse. So first you have to check the matrix, all the diagonal elements are there, A, B, C. So first write the matrix in proper form, A000, B000, C. After that you have to find out the determinant value. You have to check whether this is singular or non-singular. Yes, it is non-singular. So A inverse exists. Then you have to find out the C11, C12 in this way up to C33. Now use the formula of adjoint A. In place of the element, put the cofactor values BC 0, 0, 0, AC 0, 0, 0, AB, right? So here written directly the adjoint, and this is already in the transpose form, right? Now A inverse equals to 1 by determinant A. We know that determinant A value here ABC, so 1 by ABC into the adjoint and then multiply. If we multiply, you know that in that step BC, just simple scalar multiplication. CC will be cancelled out, BB will be cancelled out, 1 by A, same like AC divided by ABC, CC cancelled out, AA will be cancelled out, it will be 1 by B, same as AB divided by ABC, BB, AA will be cancelled out. So 1 by C, and I have written the elements 1 by A, 1 by B, 1 by C, and we know that 0 by ABC for all the cases it will be 0. So all the rest of the elements will be 0. So only after getting the inverse, you can check the given matrix was diagonal matrix, and the in that case the inverse matrix where also only the diagonal elements are present, and the diagonal elements are 1 by B, 1 by A, 1 by B, and 1 by C. So you can directly write it diag of 1 by A, only the diagonal elements 1 by A, 1 by B, 1 by C, and which is nothing but we can write that A by 1 by A equals to A inverse, and you can directly write diag of, that is diagonal elements of A inverse, B inverse and C inverse.